Hello everyone, my name is Alana and I am a part of the Innovyze team here in Asia Pacific. Thank you everyone for joining us today for our Evolution of RAFTS Hydrology webinar, where we will be discussing the new release of RAFTS in ICM, which honours 45 years of innovation and improvement in the stormwater industry, evolving Australia's favourite hydrology method for the needs of the 21st century. Now, as we wait for a few more people to join, a little background on our company. Here at Innovyze, we have a mission to empower water professionals around the world to successfully create, manage, and maintain their water services. We are the global leader in water infrastructure data analytics software, providing innovative decision-making software solutions for lasting customer success. We have over 45 plus years of experience, over 3,200 clients in around 60 odd countries, servicing the top 10 cities in Australia. Our main product families in Asia Pacific are asset management, storm and flood, sewer, water supply, operational analytics, and also artificial intelligence. During today's webinar, we encourage you to ask any questions you have along the way in the questions box to the left of your screen. Any questions will be answered either during or after today's webinar by your hosts Sophia and Matt. You'll also have an opportunity at the end of the webinar to ask questions also. Before we get going, it is my absolute pleasure to introduce you to our host for today. Sophia is an experienced water resources engineer with a demonstrated history of working in the public and private sectors. She has worked on a variety of projects, including citywide infrastructure planning, flood modelling and disaster management, design of urban drainage, including water-sensitive urban design, and the management of runoff from open-cut mines. Sophia also runs support and training on XPRAFTS, XPSwim, and InfoWorks ICM. Matthew is an experienced stormwater and water resources engineer from Brisbane with over 3 years' experience working in the civil engineering industry. He has spent the majority of his time as a designer and consultant with a demonstrated history on a range of infrastructural projects involving catchment hydrology, flood studies and mitigation strategies, drainage design, and water quality planning. With all that being said, please take it away, Sophia.
Thanks, Alana, and thank you, Matt, for joining us. It is great to have someone else on the webinar rather than me talking for a full hour. So thank you, Matt. Matt is pretty new to Innovyze, but has quite a bit of experience with XPRAFTS, and in the last 2 months has learned quite a lot about ICM. All right, so today's webinar, we are talking about the evolution of RAFTS hydrology. We've had about 45 years of XPRAFTS, and we're now moving into the 21st century. So today we're going to have a little look at what those 45 years look like and what the future really looks like as well. So to kick it off, let's have a quick look at the RAFTS history. This is not something new. I think I've covered this in a couple of webinars, but it's been around since the 70s. And over the years, we've added new features in there to kind of keep up with the industry needs. So in 94, we added in the ARNR 87, and the last big update there was 2018, where we added ARNR 2016, which is now called 2019, rainfall and statistics. So today, RAFTS is taking a huge step forward. This is not the first time RAFTS has had a big step forward. So the first time we actually went from MAP to DOS, and then in the year 2000, it was completely rewritten for the modern Windows. And now RAFTS is taking the next step, which is into brand new architecture within InfoWorks ICM. So why do we keep doing these things? It's for one reason. It's to make a better product. So we get lots of benefits when we move into new architecture. The biggest ones there, and I guess the ones that I really love, is it's much faster. We have a huge amount of flexibility with what we can do with it. And as you'll see shortly, is we've got model history, more accuracy, and we can actually do a lot of projects faster than ever before. So let's have a look at the development of RAFTS in ICM. This is not something we started doing last month, although we've been doing quite a lot of work in the last few months. But we really started back in 2017, where we put R&R 2016 rainfall and statistics in there. So you might have noticed we actually had that back in 2018 for XPRAFTS. So R&R went into ICM before it went into XPRAFTS. We added the RAFTS Hydrology and the bomb radar. We've added lag links in there and the import of XP Swim and XP Storm models. We've also got the ability to drain catchments directly to the 2D mesh, so adding integration in there. And coming in about 2 weeks will be the XPRAFTS importer. That was really the missing link in the whole system that we needed to migrate RAFTS into ICM. So along with the whole standard features that you would usually expect to get in a RAFTS model, RAFTS in ICM has a huge amount of benefits. Some things like radar rainfall we can use. We've got global support development. So XPRAFTS was only really used in Australia. So we had only a couple of developers working on that. Now we've got a full team working globally, which is quite nice. Lots of late phone calls for me in the last few months. We've got more infiltration methods than ever before. We can work with a lot of different data sets, which we really need in today's industry. So went one step too far. Today, we're really going to be looking at 3 main benefits of moving into new architecture. And those 3 benefits are the speed, integrated workflows, and the flexibility. Let's have a look at an example model. So this is going to be kind of the first look or a sneak preview of the RAFTS importer that will be coming in a couple of weeks. So we'll first off open a RAFTS model. Okay, so this is XPRAFTS. Hopefully looks pretty familiar to most people on the webinar. Very simple model. It's really made up of nodes and links. On the nodes is the subcatchment data. And on each subcatchment, we've obviously got the typical things, the area, the slope, the mains roughness, and some infiltration. And then we've got 2 types of links in this model. We've got the pretty basic lag link, which moves a hydrograph from one place to another. And we've also got the more advanced in XPRAFTS, but still quite simple channel routing. So we'll have the long section that doesn't actually have invert levels, it's just got a slope and a length. And then we've also got the channel profile there. And if we open up the kind of database, we've got some RAFTS storms in there, and we've got a few different initial continual losses as well across the model. All right, so that's all you're going to see from XPRAFTS today. We're now going to move into the next generation. So what I'm going to do there is I'm just going to go File, Export the data. We need to make sure that all the nodes, links, and global databases are ticked on, and all the variables. So I hit Export, save that one. And now, Matt, I'm going to hand that file over to you, and I'm also going to hand the controls over to you.
Thank you, Soph. You should all be able to see the InfoWorks ICM on the screen now. I'll just give you a quick orientation. You'll be able to see the geoplan or the user interface, where later I'll bring in the model and we'll make all our changes to the network. Also on the left-hand side, you'll see our master database layout. This is where we can store all the data for our project, and we can also set it up in an easy to understand way. Okay, first thing we'll do is open up the network that we're going to be working in, and that will bring it onto the geoplan. Now I'll import that XPX file through the XPRAFTS importer. So I select my file, open, and just wait while that uploads.
So if anyone's madly opening up their ICM network at the moment, Matt and I are actually using a development version, so this is not quite publicly available yet. So you guys are the first ones to actually see this.
Okay, that's all done now. We can zoom to our network and should be able to see a model similar to the XPRAFTS model that we saw before. We can also add things onto the geoplan, such as background GIS layers. Here I've got some aerial view, and I also downloaded some DEM data from Elbis previously, as we can see here. I'll just take that back off. Now let's begin by looking at some of the features in XPRAFTS that we can see here in ICM. I'm just going to also bring on one of the themes that I generated earlier so we can make the model look a little bit nicer. We can see that the subcatchment themes have changed and also our channel themes, which are now blue. Let's begin by looking at one of the channels that have been imported. We can see here the properties of the channel in the property window, and we can go and look at the shape of the channel as well. See how that's been imported. Okay, now let's look at one of the subcatchments. In XPRAFTS, the subcatchments were defined at the nodes. Here you can see that they are in fact their own objects. All the properties have been imported in, such as the area, we have our slope and our Manning's value. We can also go and view some of that global data that's been brought in. This here is our land use, the rural pervious. And if we want, we can go and view all of these values in our subcatchment grid window, going to the land use tab, and you can see those XPRAFTS global data loss models brought back into here. If we open up one of them, so I'll go and open up that, we can also see the losses associated to that particular land use. Here, for example, I have initial loss of 15 mil and a continuing loss of 2 millimeters an hour. Okay. Before we want to run the RAFTS in ICM, we need to validate the model. So we can use the validate icon on the toolbar, or we can use the validate network here in the menu tab. Hit OK, and we'll see from the output window, there are a few errors which need to be fixed up before we can run the 1D engine, and some yellow or orange warnings, which are recommendations to look at before simulating a model. We can see here in the messages that we need to connect the model to an outfall so that the engine can run. We'll go and do that by adding a new outfall node. So we want to set our new object to node and create an outlet here at the end. Going to name it out, check that it's type outfall, and hit OK. Oh, cancel that. And we need to connect the network up through a link. I'm going to create just a weir between the network that I imported and the new outlet I added. Okay, we just need to fill in some data here before we can simulate. As you can see, we have an inline validation error popping up in the properties window. So first I'm going to set my ground level and just add a width to the weir. I need to check that my outlet is the same ground level as the one I've just added. So come back, select the outlet, and enter in 0 as well. Okay, now we should be able to commit the model and begin our run. To commit your model, come up here. We can either select commit changes to the master database, or we can go within the network, right click, and commit the changes. It is recommended that you add some details when committing. This will give a log for when working in a work group with other users, so they know what changes have been made to the model. So what we did was we imported the XPRAFTS model and added an outlet. and we can validate before we commit the changes. And as you can see, the errors are now removed. I'll now hand over to Soph, who can run through the simulations and also compare the simulation with an XPRAFTS model run as well.
Thanks, Matt. So now we're going to talk about those great features in the new RAFTS in ICM over the classic XPRAFTS. So the first one is speed. And so firstly, ICM can run a single model faster than the classic XPRAFTS, and quite significantly faster as well. But also we can distribute simulations across multiple machines, which is what we really need when we're doing things like 2D modelling or lots of different ensembles with ARNR 2019. So let's open up the software and take a look. Okay, so I think it's only fair we start with the classic XPRAFTS model. It is 45 years old, so I think it's only fair we give it a bit of a head start. So before we do that, we'll just go into the job control, have a look at what the setup is. We are using the ARNR 2019 storms. So we've just got one ensemble checked on here. We don't want to be here all day waiting for models to run. So we've got the 10% 3-hour storms 1 to 10. We're using a 60-second routing increment, or 1 minute, which is actually the smallest that the classic XPRAFTS can go down to. And we're running these simulations for 12 hours each. So we'll go OK there, and we'll hit solve. And as those start simulating, we'll flip over to the same network in the new RAFTS in ICM. First, let's have a look at the rainfall. So we better make sure that we're running the same storm. So we've got the 10% 3-hour storms 1 to 10 checked on there. And then if we go into a run dialog, all right, so we're running this network with the rainfalls, that 60-second routing increment, and the same duration. So we'll hit solve there, and we'll run on my machine. And you can see I've hit simulation as XPRAFTS Classic is on to Storm 4. And if I open up the job control in ICM, we've actually, you can see the 8 out of the 10 simulations are blue, which means that they're running. Once they turn green, they mean that they've completed. And in ICM, because I've got 8 cores on my laptop, we'll have 8 running at once. And then once they're finished, it will kick over the next sims. So we can see that they're all finished now. And while we're waiting for the classic XPRAFTS to finish, we'll just have a look at the results. So I'm just going to select the outlet. Many ways to look at results in the new RAFTS in ICM. But I'm just going to do an object per page, pull in all my simulation results, select the outlet, and I'm going to plot the downstream flows. So ICM actually uses multiple hydraulic nodes along the links, so you actually get a flow at the upstream and downstream levels, and also you can get the flows in between if you want to. And I'll just plot the flows from 0 to 140 Qmax. You can see the hydrographs there. We also get the table, a bit more information, so I'll just exclude the title block and statistics tables to make that nice and clear. And now XPRAFTS Classic has finished simulating. I can also plot the results there at the outlet. So as you would expect, quite similar results. You will get some slight differences in ICM compared to the classic XPRAFTS when you're using channel links. And that's basically because in XPRAFTS we're using the Muskingum-Kunz routing, which is a hydrologic routing method. Doesn't consider the storage changes along the stream or backwater effects, whereas ICM is accounting for those things. So typically you might find that ICM will actually have slightly smaller peak flows than the XPRAFTS Classic would. But you should see quite similar results. The flatter the catchment, the more differences you'll see in those results, as you could imagine. So I think it's pretty obvious that ICM is quite a bit faster than the classic XPRAFTS,
What that means is, for the modelers, not so many cups of tea while we're waiting for models to solve, but it does mean that we can actually get our projects done on time and obviously on budget then. So the second key benefit that we're going to have a look at is integrated workflows. Going to have a quick look at kind of traditional flood modelling and stormwater modelling versus an integrated system. Looking at how we can automate some manual tasks, so those things that we do over and over again for every project, let's automate those things. And then have a look at some of the great things that ICM already had, so version control, unlimited undo, give us a single point of truth, and obviously Matt and I are using the multi-user functionality today with the conflict resolution. So here we've got a representation of a pretty traditional method of doing flood models or stormwater models in Australia. And I do say Australia because it's quite different to how we do things around the world. We call that the fragmented system, and we call it the fragmented system because we use multiple different products and methods to complete the whole project. So XPRAFTS obviously sits at the top there that does purely the hydrology. Yes, it does have some hydraulic functions, but that was never its intention as a product. It was purely to work out which hydrographs, or what the hydrographs look like out of a catchment. We then create a hydraulic model, which those hydrographs feed into. And then we simulate the hydraulics with the hydrology inputs, post-process the results, and then obviously we put that into a nice report, and that's what we give to the client. The problem with that process is, firstly, it's pretty inefficient, and it's also a little bit risky by doing all those transfers between the different platforms. But the biggest problem is if we make a mistake along the way, especially up in the hydrology, we pretty much have to start that process all again, which is pretty time consuming. So the opposite of that is obviously an integrated system, which is InfoWorks ICM. Benefits of that is obviously we don't have that risk of losing data between the different platforms. We don't have those inefficiencies between moving between the platforms. And the big one there is if we make a mistake up in the hydrology, we don't have to redo the whole project. We'll simply update the hydrology and those updates feed through the whole model. So Matt, I'm going to hand it back over to you for the hard part. If you can show everyone how to automate some of these tasks and how to do an integrated model.
Okay, thanks again, Soph. I'll just take control back.
I'm getting faster at this, swapping control.
So I guess the next step in our integrated workflow is setting up the 2D model and also simulating it, which ICM is more than capable of doing. Okay, I'll just close out this network that we had, and we'll open up the one where we're going to prepare our 2D model. I'll bring in our background, and I also want to turn on our DEM so we can set up our 2D mesh zone area. Okay, the first step is creating this 2D mesh zone. So like we did with the nodes and the links, we'll come back to our new object and we're going to create a polygon for the 2D zone. So I'll just quickly create this. Might want to just run around the top of the catchment here. And it is important to make sure when you're doing up this 2D zone that you stay within the the DEM. Otherwise, you'll have trouble running the mesh later. Double click to end, and we'll just give it a name. Okay. Now we just need to enter in a few more details before we can generate our flexible mesh. Because it's such a big model, we might want to make our maximum triangle size a little bit bigger than what we have in the default. And I might just change the minimum to 50. The boundary points, so how the flow will behave once it hits the boundary of the 2D mesh zone. I'm going to set this to normal condition so we can have flow out of the 2D zone. We'll see here an inline validation error has occurred. This is because we need to generate the mesh. So we can do that first by clicking on our 2D mesh zone model, and we'll generate our mesh. We need to bring in our DEM ground model to first generate the mesh element areas. Hit OK, and we're going to run it on the computer. So I'm just going to load that into our geoplan. There we go. If I zoom in, we can see all the mesh element areas. If I select one of the elements, I can see that the area is almost as big as the maximum that I set. So that's 220 square meters for that particular element. Now I'm going to show you how we can automate some of the tasks. Here we want to have our hydrology, so the hydrographs we generated earlier in our 1D run. We want to drain that onto the 2D surface to see how the flood will behave. So I'm just going to open up a new subcatchments grid window. Here you'll be able to see all the properties for the subcatchments that we described earlier. Currently, all subcatchments are draining to the nodes. We want to get these to drain to a 2D point source, which falls directly into the 2D domain. So as I said before, we have some stored query objects which automate tasks for us in ICM. I'm just going to drag that on. So what happened there is, if I go back into our subcatchment window, we will see that some of our subcatchments are now draining directly to the 2D zone. And we have our impervious zones draining directly to our impervious areas. Sorry, our impervious areas draining to our pervious zones. Also, I have removed the channels within the network and some of those nodes. Now we need to set up the run.
So Matt, before you do that, can you show everyone the undo button?
Yes. That's one of the great features of InfoWorks ICM, is we can go back and undo just before we've committed the changes to the network. So what my last one was running that stored query selection group. And so I'll undo that, and you should be able to see all the channels and the nodes come back into the model. I'll just bring that out back again. One of the other features in ICM is the version control. So if I were to go back into the model, the network that I'm looking at now, and show the commit history, you'll be able to see the changes that the users have made on this network previously. As you can see, Soph set this model up earlier, and I've made some changes later on. One of the other cool features, which you may have noticed as well, is these flags, these data flags. The hashtag D, the hash D is for default. And you can see these ones here where I've made the manual changes are commented with the initials MP. If we go into the user flags window, we can see all the descriptions for the flags that are defined within our master database. Okay, now let's run this model. Just open up one of the runs we had done earlier. I need to make sure that I'm using the correct network. Oh, I've missed one step. Before we run, we need to commit the changes. I'll just quickly go and back and do that. So we commit the changes to our master database, put in a comment, a detailed comment, so we know what changes occurred during this time. So we have set up the 2D zone, and we have set the subcatchments to drain onto the 2D servers. Okay, validate our network to make sure that it runs. And there are no errors. Great. let's get one of these runs going. I'll just change the name, bring in the network that we just validated and committed, and I'll run the simulation. Just before I do that, if you have GPU card in your machine, it might be a good idea to tick it on. This will perform calculations much quicker than using just the CPU engine. Hit run, and we'll run on this machine.
So Matt, alternatively, if you've got someone in your team that has a bigger GPU or a better GPU than you do, you can actually ship the simulation over to them. We didn't show that before, I don't think, did we?
No, I can quickly demonstrate where we can do that. So if I were to open up a previous run that we've done, let's just run this test. After we run the simulation, we have an option here under our scheduling to choose any of the other, I guess, machines that are associated with our workgroup network. For this example, we'll keep continuing to run the models on our computer. Let's have a look at the results. So let's go into the run that we just created, and we'll open up a new results window in the GeoPlan. We'll bring on a theme that created earlier to view the 2D network, and I might also bring on the background as well for reference. Up the top here in ICM, we have a replay window, a replay toolbar. We can show the maximum results. If I zoom in, you'll be able to see the flood theme represented in this window. And we can also go and play through the results. I might skip through some of the time steps that have been printed. And we also might want to inspect the flow at the downstream. I might quickly create a new results line at the downstream end. Out, results section, and OK. We'll use the graph tool to pick the line, and let's check the flow through the line.
Thanks, Matt. You really just showed the full process, didn't you? So you did the subcatchment hydrology, draining onto the 2D mesh to run the hydraulics, and then you even did a bit of post-processing as well of the results. So it really can all be done in a pretty efficient way in a single platform, bringing that flow back into the workflows. So the last one we really wanted to talk about was the flexibility of ICM, and also what happens when the marketing people get hold of your PowerPoint slides and do the icons for you. But in all seriousness, the ICM is much more flexible in the data that it can use, so the import and export options, and actually the real-time data that we can use as well. So one of my favorite features of ICM at the moment is its ability to use radar, both observed and forecast, which is really nice. And also just being able to get models in and out of the software quickly. And the last one there that you can see on the screen is being able to use direct rainfall and traditional hydrology coupled together. That's a really nice option, especially when you've got those catchments that are nice and steep up the top where you might want the subcatchment hydrology, and then really flat at the bottom where direct rainfall really strives. So it's really nice to have those two together. And also a little bit better than XP Swim and XP Storm is we can also run the global storms with that direct rainfall too. So Matt, we might jump back to you and you can show everyone how to do this in the software.
Thanks, Soph. Okay, let's close the results that we put up before. and I'll take out the ground model as well. So what we want to do now to show our direct rainfall is I'll also demonstrate one of the features that we Soph talked about, is importing network data from XPRAFTS, such as background images. So in our network, we can import using our Open Data Import Center.
Hey Matt, do you want to, before you do that, do you want to change the theme so that we can see the subcatchments a little bit clearer?
Sure. I'll just close out the Open Data Import Center and I'll bring in one of the themes we generated earlier. You can see the 2D zone is still visible. I might just change the display of that slightly so we can see the next steps more clearly.
Maybe just turn off the mesh elements as well. That's actually a really common question that we get, is how to remove the elements from the model.
You can see I've just changed the visibility there. Okay, back to the Open Data Import Center. Here we can bring in all sorts of data types, such as those listed here, map info tab files, CSVs, or raw shape files, which I'm going to bring in now. We want to change our subcatchment shapes. So let's select our subcatchment option. And we'll select the file. Bring in our shapefile that was exported earlier. And we want to set our subcatchment ID to our import field under ID. Now we want to overwrite those subcatchments on our geoplan and only update the existing objects. We also might want to flag these changes made so that other users know how this was changed. I'm going to set my initials and we'll import. Okay, and we can close. You should be able to see here the new shapes of the subcatchments that have been imported. I might just turn off the aerial background so we can see them more clearly. Looks great.
That's such a nice feature. I've been trying to do that in XPRAFTS for a while. And Matt, all of those things that you just showed how you could import, you can also export them out as well, can't you?
That's
through
right.
the Open Data Export Center.
So that's basically going back through the same steps, export and using Open Data Export Center. Okay, now let's continue to create a direct rainfall model. We might want to split off our network using this create scenario icon on the toolbar. So we click the icon and we'll create a new scenario called direct rainfall method and we'll hit OK. It's important to note that any changes made in the base model will also be represented in the scenario that we made, but not vice versa. I might just turn back some of the visibility into the 2D zone. Okay. And let's select the 2D zone to bring up the properties. Here we can quickly change to set the direct rainfall method on to the 2D zone. And here we're currently applying the rainfall everywhere within the zone, but we want to set it outside subcatchments. As Soph's explained earlier, is that some models we just want to focus on the flat in some areas with direct rainfall and some areas maybe just having a 2D source input. So what I'm going to do is open up the subcatchments window and we're only going to delete some of the subcatchments. So I'm going to select a few of those subcatchments and hit delete. If I go back into the model, we should be able to see some of those subcatchments that were deleted with the ghosted outlines. Now we just need to validate our model before running it and commit the changes. We tick on the scenario that we want to validate, which is that direct rainfall method scenario. We can see some of the errors have come up here within the mesh data. This just means that we need to remesh the model. So I'll select the 2D zone again, and as I showed earlier, come to meshing and we'll mesh that 2D zone. There we go. Let's bring in the new mesh. Let's revalidate, commit the changes, direct rainfall scenario added. And let's run the model. Open up one of the runs that we generated before. We'll change the name and make sure that we bring in the network that we've been working in. Make sure that the scenario we want to run is checked. And let's...
Hey, Matt, before you hit run, do you want to change the time step on that one?
Sure. We'll make sure that that goes through a bit quicker. And let's rerun the simulation. Let's open up those results that I've just finished by clicking on the result simulation icon. Let's bring in the background for reference. Bring on our direct rainfall theme, and let's hit the maxima. Here we can clearly see where the direct rainfall has been applied to the 2D zone and where the inflow from the 2D point sources are occurring. I'll hand back over to Soap, where she can show you one of her favorite features in InfoWorks ICM, the radar.
I've finished your model. So everyone should recognize this model is the 1D model that we first imported. And all I've done was add some radar. So if anyone's watching this webinar from New South Wales, the southern end, you might recognize this area. Firstly, thank you for Blacktown Council for providing this model. It is a sample model and I have modified it. So if you see your house flooding, don't be scared. It's just a sample model. The data is not real. One thing that is real though is the rain that we got over the weekend. ICM's able to bring in the radar. So I brought in the Terry Hills radar. So I'll just open that up and show you what it looks like. Right, so all we do is open up the Australian Bureau's Net CDF. We change it onto our projection because ICM's got those projections, and then we hit simulate. So I've actually run a model here. Rather than using the the rainfall that Matt has created from XPRAFTS, we're actually using that radar. So the results we can actually use either on the subcatchments, or we could actually run that on your model as well, Matt, with the direct rainfall. But if I pull in, we can have a look at the rainfall falling on each particular subcatchment. I pull this out a little bit. So as you just showed, we can play through the simulation. And we can see the rainfall actually coming up from the north and across the model. And you can see on this particular subcatchment, obviously it's different on each one. And obviously we would want to update the polygons before we create this run because these little circles don't really represent the right areas. But you can see up here, there's a big storm coming, and that crosses straight through the model.
So the new release of RAFTS in ICM really does have a lot more flexible options than the original XPRAFTS. It's really easy to update your models with lots of different data sets, and you've also got new data sets to play with. So just to summarise where we are today on the RAFTS in ICM, the next release of InfoWorks ICM will include the XPRAFTS importer, and that's due for release on the 9th of November, so just a couple of weeks away. Lastly, I just want to give a special thanks to, again, Blacktown City Council for providing some data for today's webinar, all our RAFTS users over the last 45 years, and also to those who actually provided some test models and some feedback for our RAFTS in ICM evolution. And Matt, I better thank you as well for coming along and doing all the demos.
Thank you, everyone, and thank you, Sophia, for running us through new RAFTS in ICM.
Great. All right, guys, hope to see you in the training. And if not, well, even if so, have a good afternoon.